In this lesson, we're going to look at some other problems using the solubility curve. If 35 grams of KNO3 is added to 100 grams of water at 20 degrees Celsius, how much will dissolve, how much will remain undissolved, and is the solution saturated? In the previous problems, we looked at the limits of solubility. Now we're talking about actual solutions. Remember that these lines on the graph represent the maximum amount that will dissolve of a given solute at the specified temperature in 100 grams of water. That does not mean that these are the only amounts of substances that can be added to water. First, we need to find the curve for the substance of KNO3. And then we need to look at 20 degrees Celsius, which is the temperature given in the problem. Here it shows us that we have 30 grams of KNO3 can dissolve in 100 grams of water. And what this is the maximum amount that can dissolve in that sample of water. If we've added 35 grams, we have added more than can dissolve, and so we will see that 30 grams will dissolve. 5 grams will remain undissolved, and this will be considered a saturated solution because the maximum amount of KNO3 is dissolved. Even though there is excess in there, the maximum amount is dissolved, so it meets the definition of saturation. If 20 grams of KNO3 is added to 50 grams of water at 20 degrees Celsius, how much will dissolve, how much will remain undissolved, and is the solution saturated? Based on the previous problem, we already know that 30 grams of KNO3 will dissolve in 100 grams of water, and this represents the maximum amount that will dissolve. We first need to look at the proportion for 30 grams of KNO3 and 100 grams of water and set that up with X grams of KNO3 and 50 grams of water. And when we solve for X, we find 15 grams, and that tells us the maximum amount of KNO3 that can dissolve in 50 grams of water. We see that we have 20 grams of KNO3 that have been added to the 50 grams of water. So the first 15 grams will dissolve. We will have 5 grams that remain undissolved, and we will have a saturated solution because the maximum amount of KNO3 is dissolved in water. If 50 grams of KNO3 is added to 200 grams of water at 20 degrees Celsius, how much will dissolve, how much will remain undissolved, and is the solution saturated? We know that 30 grams of KNO3 can dissolve in 100 grams of water, and this is the maximum amount that will dissolve. Because we're dealing with 200 grams of water, we need to set up a proportion to determine the maximum amount that will dissolve in 200 grams of water. When we solve for X, we end up with 60 grams of KNO3, and this is the maximum amount that will dissolve in 200 grams of water. We've added only 50 grams of KNO3, so we see that 50 grams will dissolve, 0 grams will remain undissolved, and this will be an unsaturated solution because we could continue to add up to 10 more grams of KNO3 and it would still dissolve. Because we have less than the maximum amount dissolved in water, we see that this is an unsaturated solution. Let's look at a different type of example. 60 grams of solute is added to 100 grams of water at 50 degrees Celsius and dissolves completely. The solution is cooled to 30 degrees Celsius and some of the solute precipitates out of solution. Identify the solute. This problem has two parts. We have our initial solution, which is at 50 degrees Celsius, and then we change the temperature to 30 degrees Celsius. Before we look at the second conditions, we first have to see what is possible given the first set of conditions. This problem can be solved through process of elimination. We look at our first set of conditions given in the first two lines, and we're going to see what substances can be eliminated as possibilities based on this description. Then we will look at what happens after we do the temperature change. So first, we want to see we have 60 grams of solute is added to 100 grams of water at 50 degrees Celsius. So I'm going to draw a point on the curve to represent that data. And it tells me that it dissolves completely. I need to determine whether or not I can eliminate the substances that have solubilities greater than that point or less than that point. So I'm going to look at an example with KCl. Notice that for KCl at 50 degrees Celsius, I can get about 42 or 43 grams of KCl to dissolve. If I were to put 60 grams of KCl, it would not all dissolve completely. This lets me know that I can eliminate KCl. The same argument could be made for NaCl and all of the other compounds whose solubility is less than KCl. So we can eliminate all of the lower substances as possibilities, because if I added 60 grams of any of those, it would be greater than the maximum amount that would dissolve and therefore would not dissolve completely in the 100 grams of water. This leaves me with four options for those compounds whose solubility is greater than 60 grams per 100 grams of water. Now I can look at the second set of conditions where I see the solution is cooled to 30 degrees Celsius. At that point, some of the solute precipitates out of solution. We're going to draw a second dot at that point at 30 degrees. Just like before, I want to look and see which substances I can eliminate, the things above or the things below that solubility point. If I looked at lead nitrate or PbNO3 I see that at 30 degrees Celsius, about 65 grams of PbNO3 would dissolve in 100 grams of water. And all of that 65 grams would dissolve. This does not fit the description given in the problem. It said the solution is cooled to 30 degrees and some of the solute precipitates out of solution, which indicates that we are above the maximum solubility. 60 grams of PbNO3 would dissolve at this temperature, as would 60 grams of CaCl2 and NaNO3, so I can eliminate those as possibilities. Therefore, the only substance left is KNO3. Note that I still had KNO3 for my first data point because its solubility at 50 degrees Celsius is about 88 grams. So if I put 60 grams of KNO3 in 100 grams of water, it would all dissolve. However, if I have 60 grams of KNO3 at 30 degrees Celsius, it would not all dissolve because the limit at 30 degrees Celsius is about 45 grams of solute per 100 grams of water. Remember, the lines on the graph show us the maximum amount that will dissolve at a given temperature.